Yeah, some of things we did not discuss. We'll discuss this metadata and other things at the time of um, big query, big table kind of things. So internally, we'll use all these things again. The health checkup and other things when we use some processing related things. Okay. Yeah, right. Create a disk. So zone is common. We can select any one of the zone which is nearby us or which is less price. So basically here the disk types are standard and persistent. This one, right? Yeah, SSD is a faster one, right? SSD is always it will be work like every for high performance related thing. Standard disk will give you the normal standard disk type. If then here we can create select the image. If you create an image, you can choose the image from here. Before selecting the disk, we can create an images. Here you can see there are n number of images already created. You can choose any one of the image here. These are belongs to different kinds of operating system. CentOS 6, CentOS 7. If you click here, you can see this is the operating system is CentOS with the 6 x86 server. Okay, type is 86. Okay, built on suppose this is the date. So you can take by default this as a image, or else if you want to choose a specifically separate instance, then you need to create an instance template. Image is already there. You can choose any one of the images, or if you want to create your own customized one, then you can create your own thing. Here there are n number of images are there, not only the operating system level. You can see SQL level and all kind of images already created. When you do something, automatically it will create an image. Okay, when you create instance template, you need to create new instance template here based on your requirement. Okay, so mainly here we need to concentrate on instance template, instance group, VM instances. Okay, in my project we are using approximately 115 VM instances we are using. Okay, 115 instances. Out of that we have created the 4 different groups. Okay, let me show you those. I cannot show that here. From it's completely from client server. So my groups are dev, offshore, cluster. Okay, test, offshore, cluster, and we have found in dev some other dev 2 also there. Dev 2 cluster is separate cluster. Is there. So like that we have created different instance groups. In each group is belongs to some instance templates. So by default we'll pick those templates. So those templates will be available in the VM instances here, the list. Those list we can see here when you click on the cloud platform here in the dashboard. You can see the resources, how many app engines, how many compute engines are there, right? As of now, you are not able to see any compute engine right here. So if you go back here, just let me create one app engine. While creating, request failed, no error. Just click on create. What happened? Yeah, okay. Now I'm able to create. Just have refresh it. If you get any issue while creating something, just you can refresh, automatically it will reset it. Okay. Instance GCP instance test 123. Just if the same name is available, it will not allow. See, if I use instance test, it is not there, so you can create. So you can use it. Everything is same. Here you can see the boot disk. What kind of disk you want? By default, it is selecting Debian Linux 9, right? Here also we can change the disk. What is the type of disk? Okay, I wanted to select CentOS 6. Here SSD or normal standard. So if I take SSD, it will be more faster. You can see much less expensive for standard primitive disk. Got it? Here you can see the message. Normal one is less expensive for the standard version disk than SSD. And SSD version disk is better for random IOPS, input output processing services or streaming throughputs. Okay, with low latency. Latency is nothing but fast accessing from client to server, server to client. Okay, here they have given very clearly all the details. Standard percent disk, SSD percent disk. This is the efficient for reliable block storages for better, just for storage purpose. But SSD will be useful for fast and reliable block storage. The request and response will be very, very fast. Okay. So maximum space, for instance, they are providing 64 terabytes of space. They are providing. So these are normal things. What are the features? What are the scope is available in GCP? They are giving data redundancy is there in all the two things, and encrypt at rest encrypting is there in all the levels. All machine type support, all types will be supporting these two things. Okay, so and GCP is providing perfect documentation for everything. So you're when you're storing data, when you're going to store huge amount of data, then better to go for standard persistent disk. When you are going to use this instance for a request response purpose, for web application deployment, better to use SSD. For big data storage purpose, better to use normal storage. Standard select. So I have taken the CentOS with the standard persistent disk. Okay, here HTTP, yes. If you want to allow both the things, better you can select, or else it will take the by default one. Okay, next click. Then, so if you click on the Google Cloud Platform here, you can see App Engine is there, Compute Engine there. Okay, okay, Rahman, is this fine? Got it? SSD disk, standard disk with, yeah, thanks. Any more doubts from Rajesh or Sudhir regarding app Compute Engine? Yeah, when you create different kinds of things, so just create 5 to 10 different types of instances and delete it. Create instant, delete it. It will not cost anything. Okay. And next is the yesterday we have gone through with App Engine, right? App Engine. In App Engine, we have deployed one simple Java application here, one sample Java application. Okay, and you can see here, this is the URL for that. When you click on here, it is loading the web application. It is deployed in Google Cloud Platform. It is working properly. Okay, so let me show you some of the things when we deploy the things, what are the different environment. So this is the architecture for hosting a web app in Google Cloud, basically. Okay, So application can be iOS, Android, or any normal desktop application. Any application, if you developed anywhere is fine, no issue. Okay, yesterday we have gone through the things in within the Google, right? Already someone is developed some sample. The Google itself is developed some sample. We have taken that example and we deployed it, right? So in normally in generally in real time environment, Java developers will do development in the local environment, like Eclipse will be used, right? Rajesh, I think you are from Java background, so you will use Eclipse in your local machine, correct? So when you develop your application in your local machine, all the Java files and web app, all jars, everything will be available in your local. So then if you want to deploy it to cloud, it will be little difficult. You cannot copy all the things to cloud directly and you cannot deploy, right? For that purpose, they are providing integration plugins from your local machine to cloud platform. Rajesh, are able to get? So, so here, what are the application you are deploying from other third-party systems, but the App Engine will take the requests with the Google Load Balancer. Google Load Balancer will be here available. Based on the load, it will be execute the, it will be deploy and execute the services. Okay, so App Engine will be the available as a front-end app. In between backend data and here client side. In middle we have a app engine. Okay, app engine will be used internally all kind of systems, so storage systems, like it will use databases, it will use static content. Any data is available in a static content in the web application containers. Application servers are containers and it will executing in the backend app engines also. Okay, why app engine? App engine will execute the data. It will be auto scaling, right? It will do the auto scaling. Here the Google is mainly focusing on auto scaling area, even in app engine, even in uh, compute engine also. Okay, both areas. So what is exactly auto scaling? Okay, so any idea about auto scaling? Do you have any idea about what is scaling? Scalability is nothing but the one of the uh, basic feature of distributed architecture. Distributed architecture feature is scaling. Okay, there are two types. Scaling is nothing but increasing the resources, increasing the system, increasing the anything. If you want to increase, you can increase that one. That can be called as a scaling. Okay, here scale up, scale down. Scale up is nothing but increasing, increment. Here decreasing, right? It's a decreasing. So like that, increasing and decreasing. Scaling up will always will update the resources or add the things, add new resources simply. Okay, here remove existing resources. Okay, what kind of resource? It can be anything. Not only in the computer world, in a general scenarios also we can say adding resources is nothing but scaling the things, scaling the existing environment. If you have a laptop with 4 GB RAM, if you increase to 8 GB, that is scaling up, or 16 GB to 30 GB, scaling up. If you remove one of the slot in the RAM, 16 to 8 GB, that means scale down, right? So in distributed architecture, when the systems are not sufficient, automatically we can add the new machines. Automatically, it will take the new machines into the cluster. Okay, so this is called scaling or scaling up, scaling down. So in scaling up, we have again two types of scaling: horizontal scaling and vertical scaling. What is horizontal and vertical? Vertical scaling is like increasing the systems like this, adding new things in a on top of the same way is a increasing the vertical. It's a vertical scaling. Okay, horizontal scaling like horizontal will be like it's increasing the things like this, adding the new things like this, expanding the things. For example, you have a one machine, one computer with 4 GB RAM and 1 TB hard disk. If you want to increase to 8 GB and if you want to increase to 5 terabyte, it is vertical scaling. Again, from 8 GB to 16 GB and 5 to 10 terabyte, again it's a vertical scaling only. Because of within the same system you are increasing, but always vertical scaling will not give you performance. Somewhere it will be the bottleneck. It cannot provide completely high end. Okay, because of the processor may need to support for a 16 GB or 32 GB RAM, right? Horizontal scaling is like nothing but instead of you have a one computer with 8 GB RAM and 1 TB hard disk, so you can add one more machine. You can add one more another two more machines with maybe 4 GB RAM and 16 GB RAM, like that. We are increasing the machine resources here. This is called horizontal scaling, right? Now you are also increasing your knowledge or capabilities in horizontal way only. Okay, Sudhir from DB background, right? But he is not learning again DB database, one more database, not like that. He is learning with some big data skills as well as with some cloud computing skills. That means he is increasing his scale, he's scaling up his knowledge in a horizontal manner. Okay, the Rajesh is learning already Java, but still he learned again Scala. He learned Python after Java, again Python. Okay, Scala. That nothing but vertical scaling. But now here is he's learning different verticals. So urgently even Rahman also. So you are all are learning you are increasing your scaling up your skills in a horizontal manner. The always horizontal scaling is very good in any scenario, even in a programming time, even in a performance time, or computer increasing the hard disk, or even in our real life also horizontal scaling is always good. Okay, did you get it? What is scaling? Scaling up, scaling down, and horizontal scaling and vertical scaling. Here we are discussing about the auto scaling. Auto scaling is nothing but it scale up and scale down automatically without having any interruption, without doing anything. It should be auto scaling. In the cloud area, yeah, you can see this one. This is completely auto scaling because of what is app engine will be useful for application purpose. As we discussed in the last section, so you have implemented one application for your business. That is like, let's take it's a e-commerce business. So initially you have implemented a end-to-end database and a web application with a very rich GUI, graphical user interface, but the customers are very less. Maybe per day you may see very less customers you are getting, but you have chosen uh, in the app engine. By default it will take the existing app engine infrastructure, so you are not selecting any other infrastructure. That means it will take SSD hard disk, which will be useful for fast extraction, and I can say it will be useful for requesting and responses purpose. Okay, sorry, I think Ramkoti joined rest now, right? Yeah, hi Ramkoti. Yeah, could you please try to join little early, just 15 minutes early, possible? Yeah, just we were discussing about the architecture of how to hosting the app engine, and we discussed uh, just now what is the scaling. Okay, scale down, scale up. Okay, did you have idea about the scaling? And we discussed about the vertical scaling and the horizontal scaling, all these things. Okay, okay, yeah. Just you can see the it is record. This is recording. Just you can get it. Just 5 minutes I have explained. If you have any doubts, please let me know. Tomorrow I will explain once again. Okay. In the distributed architecture, we have discussed already, Ramkoti. Automatically adding the new machines to the existing system is called as a scaling. So here, why we are discussing this scaling? Here, the Google Cloud Platform is providing the feature called auto scaling. By default, the based on the request, the utilization will be increased. Utilization automatically it will take care of it. Okay, here app engine will be the front end app. Okay, it will be taking all the requests from the customers, whether it whatever the customer, it can be mobile or desktop. It will take the all the requests. Based on the request, it will send the it will take the data from the backend data. See, cloud SQL, cloud data store, these are the data stores like a databases, you can say. When you have when you enter a request, it should check with the backend database, right? Or cloud storage. Static content, this is the dynamic content. Based on the data availability, it will send respond to the client, right? So whenever one, if you enter a browser, just you enter a user ID and password, then you can enter a submit button. Then what will happen exactly here? The request will send to the application server. Request will send to the application server. Here, the program, Java program or Java web application, I can say web application is deployed. It can be a Java or any .NET or any programming language. It can be anything. So here, it will take the request. First, it will check whether the user ID password is right or wrong, right? It will take the data through HTTP or HTTPS protocol. Let's take HTTPS. Most of the people we are using HTTPS. When you use HTTPS, the user ID password which we are sending will be encrypted here, and it will be sent through across the network as an encrypted manner. Once it reaches the web application server, it will decrypt the data here, and it will compare with the database, right? Is this correct? I hope you understood. You can understand this particular process. This is a basic thing. If even if you open any web application, it will be happen common. Okay, so when you enter the submit button, it will be encrypted manner, or else somebody may capture the data here, and they may use it, right? So that is the reason we have to use HTTPS protocol. That is good for us. Okay, so then it is going to check in the database tables whether it is correct, then it will send the appropriate page, home page. Then once you browse something else, everything will be coming here, and a cross check here, and a check with the database and provide the get the data and provide like this. So this is called latency. So sending request from here, when you enter some submit button, some button, it will go here and it will verify, get the data, proper data from here to here, and send the response. This is called latency. Turn around one request, called one latency, right? So this latency will be should be very less always. Then only it will be good. Performance will be good. Okay. So in auto scaling, what will happen? In general, on premises, what is on premises? Any idea? On premises and cloud premises. We cannot say cloud premises. On premises are cloud. On premises is nothing but our own systems at our office, local, right? Okay, if you choose for on premises for same application, so you may need to use 32 GB RAM, SSD hard disk for faster access, and maybe 10 TB hard disk. So maybe if you are choosing these kind of machines to maintain the request and responses. But initially, when you are implementing your application, maybe only 2 GB RAM is utilizing, not even half of the GB. And SSD also not using properly because of requests are coming very very less because of this new business. Okay, so even you have to install complete end-to-end high-end software hardware, which you need to invest a lot of money here, right? But and maybe after 6 months or 1 year, if the 32 GB is not sufficient, the requests are coming 1,000 to 2,000 requests are coming every 1 second. The business is very good. Then 32 GB RAM is not sufficient. The requests are taking a lot of time. Immediately, you cannot so increase the system sort right automatically. But in the case of December, November, December, in US and other countries, the sales will be very huge. At this point of time, you cannot increase to 32 to 64 GB RAM. Again, from the January 5th onwards, again, the sales will be less. That 16 GB RAM is more than enough. So only for 1.5 month, if you want to increase 64 GB RAM, after that again you are utilizing only 16 GB RAM. So which is not, you are not properly utilizing your resources, right? So that is the problem. So if you go for cloud, when the requests are increasing more, automatically the resources will be increasing. Automatically it will take the one more instance and it will utilize it. Got it? That is called auto scaling. That auto scaling also we can provide here in compute engine itself. Here you can see, you can go here. When you want to add new instances and other things here, let me click on edit. Do you remember always when you want to edit something, better to stop the VM instance and then you can change the things here. Okay, here you can see machine type. These are the things here. Disable utilizing other things here. So BigQuery, all these things are disabled. You can enable if you want to use this instance for other purposes also. Automatic restart recommended or not. Availability policies, preemptability, you understood, right? Preemptability is the very cheaper hardware. We are not sure when it is going to be restart, but for the small things and quick things, you can use the preemptable one. Here you can see, yeah, let me check, where is it? Instance template, no. Yes, so we can set it so there based on our requirement. So we can set auto scaling when the CPU utilization is increased more than 80%, then we can start new thing. Yeah, yesterday let me show you that should be available here only. We can set how many instances you want to increase, how many instances, what is the maximum instances you want to create. Those things you can set here. Create new instance group. instance. See here you can see there are multiple things are there. CPU utilization, disk bytes, disk operation, network bytes. You can choose anything. Auto scaling. If the CPU utilization more than 80%, then take the another one. If the disk bytes are crossing this level, take the another instance or even byte. You can choose anything. But mostly we'll use the CPU utilization. When requests are increasing, by default CPU utilization will be increased, right? So in the same way, you can take that into the consideration. Here automatic you restart. It should be here only. Where is it? Let me create new instance. Bucket storage, cloud SQL right here. Compute engine. Allow default access, allow full access, set access. These are the access specifiers. How do you want to access this one? Manage disk networkings here. Automatic restarts. So these are the things. Did you remember where we have seen yesterday? Yesterday itself I have explained regarding this, right? Deploy container image to VM instance. This is a customization for the machine type. How many cores, how many things we want to create. Let's stay, I think in App Engine. Go to App Engine here. Traffic. Based on this is the traffic, right? Yes. Yeah, sorry, we need to do the auto scaling in App Engine, right? Not in Compute Engine. Compute Engine only will give you the instances. That's fine. But in the App Engine, when we are going to utilize the app, then we need to set the things here. Okay, so you can create one app engine. In App Engine you can check, so we can set the things here. Okay, Sudhir, just to create one app engine, it is already created here. So in this app engine, you can set the things. How do you want to verify it? How do you want to do the auto scaling here? Okay, here this is the one. Instance auto scale. See here, one instance is already created for this one. It is auto scaled. Automatically, the scaling will be happen here when it is required. Okay, this is the default one. So just let me delete this one. We'll see. I'm going to delete this instance. So automatically it is showing auto scaled. When it is auto scaled, by default it is take. If it is more than 70% of the uh, resource are using, automatically it will create the one more instance as it is. How, what is the current instance, the same thing will be created. Yeah, okay, just I was checking in Compute Engine, not in computer. We have to verify it in App Engine. Okay, yeah, let me come back to the, so this architecture is understood, right? So this is same as This one, when one request is coming from any browser or any web app, this will be checking here and it will communicate with database. Generally, the normal applications are connecting with only SQL databases, but nowadays these are connecting with the some static data, or these are connecting with the some NoSQL databases also. Okay, how many of you are aware about NoSQL? NoSQL database. NoSQL is a new thing which is new. It's not a new, it's already there in the industry, but everywhere, every company is going to migrate from SQL to NoSQL nowadays. Okay, who are not aware about NoSQL? I think Rahman, you don't have any idea, right? Rahman or Ramkoti? Yeah, okay. I'll explain very clearly what is NoSQL. Maybe because of when we are going to start with big table, we will discuss that one. You know SQL, right? RDBMS databases. Okay, okay. Yeah, fine, fine. Okay, Sudhir. So here, the App Engine environment will be like two types. One is standard and flexible. In standard environment will be automatically happen everything. If you choose standard one, automatically it will be auto scaling. Okay, because of in the standard environment, it will be taking pre-configured environments. I can say it's completely serverless. You need not worry about the server. Automatically it will take care of everything. But it pre-configured with the Java 7 or 8 and Python 2.7 or Go, PHP, some of the languages it will take it as a predefined, pre-configurable one. So when you choose this standard environment, by default, everything will be taken care. Instance, the classes and determines pricing, everything will be very less and optimized one. Okay, and all the services will be available. So what are the services you are using? You need to pay only for the uses. That's it. So always standard will be good, but when you are utilizing normal predefined things. Okay, but we have a flexible things also. Suppose I wanted to use Java 8, which is not available in Java in GCP. As of now, GCP using Java 7 or 8 also as a standard. But if you want to use Java some other version or 6 or some deprecated or new version, then you need to go for the flexible. Again, this is nothing but you are creating your own compute engine. Okay, again you are creating your own infrastructure. Creating infrastructure means not on premises. In the cloud itself, you are choosing a cloud based infrastructure. Okay, so this is a flexible one, but standard one will be completely serverless, and you can use a list of services. So whatever service you are using, only you need to pay for that. Okay, so standard engine, in the standard engine, these are the different features are available. So based on the container instances running, Google infrastructure only it will provide. It will provide only Google infrastructure. Okay, it cannot utilize other infrastructure which Google does not provide for this particular instance. Okay, basically it's a predefined. Some images, some templates are there in the inbuilt in the within the Google. So only those can be used for the standard environment. Basically, these things are more than enough. No need to go for something else. Okay, pre-configured with the all the servers and other things here. Several runtime. Runtime is nothing but programming languages, Java, Python, these things. Okay, and each runtime and each programming language includes all the libraries within the instance. You need not copy, you need not download everything. Everything will be available here itself. Okay, and it will support complete app engine standards. Okay, and these all are you need not delete anything, you need not get extra things. Everything is required here in standard. Okay, and in standard all the application will execute by default secured environment. And you need not worry about the security related things, setting the securities, other things, nothing to worry. By default, it will execute in a secure environment manner, secure sandbox environment. Okay, and here you can see it's a completely scaling. servers to meet the traffic demands. Yeah, this is called auto scaling. Based on the traffic demand, it will use the servers, multiple servers, not only one server, based on the request, right? See, App Engine stands environment distributes requests across the multiple servers and scale the servers to meet the traffic demands. Okay. So this application, whatever the application you are deploying in a standard environment, that will be executing within the one secure, reliable environment, right? So you need not worry about the hardware. The hardware, operating system, and the physical location, everything will be already captured by standard environment. But in case of flexible environment, it will allow you to customize your runtime. What is the Java or Python or Scala? So do you remember Scala is not available in the App Engine, right? Here you can see in the App Engine, you can download here App Engine. Show info panel. When you click on, already I have created one thing, right? That's the reason showing like this. You can go to the help here. You can enter the App Engine. In App Engine, you can see yesterday we have seen, right? Download App Engine SDK. When you click this one, see it is asking for the standard environment and flexible environment. Here you can see. So if you are working with Python, Java, PHP, Go language, all these are comes under standard environment. So you need not worry about anything. Simply, very easily you can build Java, Python applications. Okay, in flexible environment also Java is available. Again, you can choose what kind of Java version you want to use. Okay, Java 8 or Java and other things. What are the things you want to use here? Okay, so if anybody want from Java background, or if you want to become a cloud Java developer, you have to download any one of these things into your local environment. I think Rajesh, you can download this Java standard environment. You can add this as a plugin to the your local Eclipse environment. You can build one application, one Java program. Directly, you can deploy the Java application from your local machine to Google Cloud Platform. For that, they are providing these are the uh, libraries. Okay, download the install the SDK for App Engine. For Google App Engine, you are downloading Google supported SDK, Software Development Kit SDK. Okay, Rajesh, can you do this one? Maybe others may not be because of this not really 100% required. If you are interested, you can download it. You can develop one Java simple servlet, and you can deploy it. Okay. So these are the one is the standard environment and the flexible environment. So and the custom runtimes also. If you want to select any other programming language, you can select and you can get it. Okay, you need to get this one. Even for the virtual machines and using your own DAO profile, everything you need to set for flexible environment. Maybe most of the projects will be using flexible environment only because of the Google, which Google provides is a limited one, only Java, Python, PHP, right? If you are developing your project in some other programming language, 100% you need to go for flexible environment. Okay. These are Google functions. We can discuss Google functions later. As of now, any doubts? Today, I would like to ask you create a just one app engine. Go to app engine, just a simple already one Java program is available, right? On the right side, you are able to get the all kind of help, the commands. Just to open this one. This is the active Google Cloud Shell. Before that, please try to practice the at least 20 to 30 basic unit commands I have shared with you just now. Please practice those things, and at the same time, just to try to create one small app engine. Okay. The Kubernetes engine will be mostly useful for the DevOps people. DevOps people will be using this. We will see some of the simple things by creating the one Kubernetes cluster maybe tomorrow by discussing more about the app engine. Please try to create. If anybody is not able to create, we can do it in the session itself. I can take your I can give you the presenter to you. You can share your screen and you can create one. Maybe Rahman or who is from different background. So maybe Rajesh can do, Rajesh or Sudhir. So Ramkoti or Rahman can do it. So okay, just you can create only one or two app engine instances. That's more than enough. Okay, can do. Okay, I'll prepare a document with the commands. Yesterday we have seen some commands, right? I'll prepare those commands with you. So, but even yeah, okay, Ramkot. So please try. Even if you are not able to do, just to try one to two times, or else we can do it tomorrow. Then we can discuss something about Kubernetes cluster, just as a basic level. Okay. After that, we can go for the storage. In storage, we need to discuss more about a big table. Here, when we are going to discuss about the big table, we will discuss about the something like Hadoop. You will get some Hadoop knowledge also. What is the file system? How it will be retrieved from file system to table? How to retrieve the data? Big table mostly useful for analytical purpose. Here you will get the knowledge of analyzing the data also. You will get the knowledge of Hadoop related knowledge, even get the analytical knowledge with big table. Okay, big table is very important. It will be useful for you. You need to more focus on big table here. Maybe it may take little more time. I need to explain many things in the background of the big table also. Okay. And, data storage is normal, just storing in the buckets, and I'll show you SQL also, how to create an instance in a database, SQL database, how to create a database, how to utilize it. We'll discuss all these things. It will take more than a week time. Okay, these are the basic things. So computing engine, app engine is the basic things. If you're clear about it, then you can go for more advanced things. Okay, so I would like to stop it here. Please try to practice Unix commands as well as try to create a one instance if you are not created still, and then please create a one app engine instance. Okay, that's it. Great. Ram, could you please watch the video for first 15-20 minutes for auto scaling and scaling purpose. You can get the points. Okay, guys. Do you have any more doubts, or can we conclude the session? Yeah. Okay. Thanks, guys. Have a nice day.